Hello everyone. In this lecture, we'll cover the concepts and example problems of exercise 11.3. So let's move forward and try to discuss what are they. So far, you have gone through. First, we have seen the trigonometric ratios, then we have seen the angles, and now it comes complementary angles. Let's understand what actually it is. And see, so this is a quadrant, and in higher classes you will learn about the second and third quadrants, or you'll understand about actually what this quadrant in quadrant geometry, but use of these coordinates in trigonometry you will see in your higher classes. In 10th we require only the first quadrant, that is 0 to 90 below 90. Okay, so what about this? Thus there is a first complementary angle, that is sine 90 minus theta is always cos theta. Okay, so whatever if you'll find, so sine 90 minus theta is cos theta. Instead of theta you can tell a, so sine 90 minus a is cos a. Okay, similarly cos 90 minus theta is sine theta, tan 90 minus theta is cot theta, cot 90 minus what you can find the resemblance is tan is converting to tan, tan is converting to cot, and cot to tan. Similarly secant 90 minus theta is cosecant theta, and cosecant 90 minus theta is secant theta. Thus in every lecture I am explaining the concept first and then examples, and then after I am taking you through exercise. So the main idea behind this is, if you can go through the concept and if you're well aware of the concept, you'll easily able to solve the question regardless of the toughness. Okay, so this is the main reason behind why I am taking you through the concept. Okay, so let me tell you once again. So whenever you find sine 90 minus theta, so it is cos theta. So here it is not yeah, even you can think it is not about the inverse, that sine is inverse of cosecant. No, this is a related one. Okay, so sine the nearer one, you can say. Okay, you can even remember in this way. Let's get on to the example, then you'll understand it clearly. So the first example is evaluate secant 35 divided by cosecant 55 degree. Thus as we have seen in the earlier complementary angles, that is secant 90 minus theta is cosecant theta. Thus to secant 35, what we can write, 90 minus 55, is it? And 90 minus 55 is nothing but secant of 90 minus theta is cosecant theta. Thus we can write it as secant. And here you may get one question, that why we are writing this as 55. Okay, the so how we'll get 35? So once if I remove from 90, if I remove 55, then what I'll get? 35. Okay, and 90, whenever I use 90, so it directly changes, so it changes into cosecant. Okay, so this is what. Okay, so 90 minus whatever the requirement. Thus secant 35 is equals to cosecant 55. So cosecant 55 and 55 gets cancelled, and we are left with 1. Okay, so even in exercise problem you'll find the same. Next is ninth example. If cos 7a equals to sine of a minus 6, where 7a is an acute angle, then find the value of a. Okay, so why it is using acute angle? Because in till uh, till 10th standard we have to use only the acute angle, that is below 90 degree. Okay, yes, so let's have a look. Cos 7a equals to sine a minus 6. So can we write cos 7a as 90 minus 7a, as we have seen over there? Sine 90 minus theta equals to cos theta. Okay, so similarly we have written, and here already we have sine, so sine and sine gets cancelled, so we are left with 90 minus 7 equals to a minus 6. Then just send this 6 over here and 7 to this side. Thus we are left with 90 plus 6 divided by 8a, and 8a is equals to 8a is equals to 96. Thus a equals to 96 by 8, and it is equal to 12. 8 is 96. Thus value of a is 12 degree. If you'll get on into your higher classes, so over there you may be asked that what is the obtuse angle. Okay, so it is not an acute angle, so what the value will be. Thus 7a, clearly it is mentioning about that it is an acute angle. To be precise, a is an acute angle. It means the value will be less than 90. Okay, let's move on to the example 10. 10th example. Yes. So if sin A equals to cos B, then prove that A plus B equals to 90. Very easy question. Within you can even extend the steps that are given and all this by writing. Okay. So the given is sin A equals to cos B. Where is it? Here it is. Okay. Yeah. So sin A equals to cos B. Thus we can write cos B as 90 minus B, or even in the side of A you can write sin A as cos of 90 minus A equals to cos B. Either of the way you can try, and sin gets cancelled, so we are left with A equals to 90 minus B. Thus A plus B equals to 90 degrees. Okay. Next move on to 11th one. Express sin 81 plus tan 81 in terms of trigonometric ratios of angles between 0 and 45. Okay, why to be precise 0 and 45? Because if you'll see in answer, we have to get in between this, and we'll prove why we'll get only this. So sin 81 plus tan 81, how can we write in terms of this? So sine of 90 minus theta is cos, so 90 minus 9 is cos 9. Here it is. And tan of 81, that is tan of 90 minus, so what is tan 90 minus theta? It is cot theta, that's it is cot 9. Thus sin 81 plus tan 81 is equals to cos 9 plus cot 9. Okay, let's move on to the last example of the exercise, that is example 12. If A, B and C are interior angles of triangle ABC. Okay, so to be precise, it is given this one, A, B and C. Okay, so this is A, this is B, this is C. Okay, so these are, and exterior angle is nothing but let me tell you what actual exterior. So this one is the exterior angle. Okay, so here we are talking only about the interior, so these are the interior ones. Yes. So A, B and C are interior angles of triangle ABC. Then show that is nothing but prove that sine of B plus C by 2 equals to cos of A by 2. So here B plus C, B is nothing but angle. Okay, so how we can prove this one? Let's start with the solution. So sum of all the interior angles of a given triangle is equal to 180 degree. Okay, next what we are doing, we are just dividing by 2 on both sides, and if we do the same task on both the sides, so the result will not get affected. So as we have divided, so what we require, b plus c together, and a as an individual. Okay, so a by 2 plus b plus c by 2 equals to 90 degree. Okay, thus b plus c by 2 equals to 90 minus a by 2, and then just add just add sign on both the side, just multiply with sign, then you'll find sine of b plus c by 2 equals to sine of 90 minus a by 2, and sine of 90 minus theta is nothing but cos theta, that is nothing but cos a by 2. Okay, yes. So that's all for that's all about the examples, and we'll see the exercise problems in our next lecture. Thank you.